Hello there, Math Analyzers. Welcome to your Chapter 9 overview and your Chapter 9 Lesson 1 notes. So first, let's talk about what we're going to do in Chapter 9. It is called the unit circle. So we are going to finally put together all that equation solving work we've been doing at the Algebra 2 level this year, as well as take all of Chapter 8's reminders of trig and right triangle work in geometry. And we're going to put them together into a unit circle on a coordinate plane, okay? But before we can really officially do that, we need to talk about radian angle measure, and we need to talk about rotations and angle terminology. And once we kind of have those two concepts down, we can take the stuff we already know and put it all into one circle on the coordinate plane. And then we'll identify important specific points along that unit circle. That's what our quiz will be on. So that's where we're going to stop and then have our quiz. After that, we're going to take our trig to the next level by applying it through the unit circle. We'll start to put some pieces together that will really make us understand the sine and cosine functions more deeply. And then we'll add tangent to the mix, and we'll kind of understand how those will all come together in the unit circle. Then we're going to take that unit circle and we're going to stretch it apart. That's what creates the basic sine and cosine function graphs. That will lead us to Chapter 10. So this is how we want to kind of go slowly into the real higher level trig work that we've been doing, or that we've been building towards, I should say. Now, let me just say that on the next page of this, I have listed some of the extra resources that I will use and assign. So sometimes I'll kind of lace these within my videos, and sometimes I'll mention them within my notes or within my videos, or maybe assign them separately. Either way, I will convert all of them and have them available to you. Okay, so either way, you'll have them. I know you can now access YouTube, but still, I have them converted before we could access YouTube, right? Speaking of lacing things within my videos, this first lesson, all about understanding radian angle measure, and then using that to convert back and forth between radian measure and degree measure to talk about an angle's length, an angle's measurement. That is from all these pictures are screenshots from a YouTube video. So I've converted it. I'm going to put it right into this video so you can watch that first. And then because the person doing it does speak very fast, I'm then going to go through each of these key points of the video to make sure you understand. And then we'll start to do conversions from radian angle measure to degree measure and vice versa, back and forth, right? Okay, so giving myself a second to have a pause so that I can now put in your video. 5 minutes. I'll see you guys in a sec.
In the previous video, we looked at how angles are measured using degrees. This angle would measure around 30 degrees. A right angle would measure 90 degrees, a straight line 180 degrees, and one complete rotation 360 degrees. Do you know why 360 degrees? It's somewhat arbitrary and had something to do with the base 60 number system. Do we have some other way in which we can measure angles such that it makes a little more sense? Yes, that brings us to the concept of radians, and trust me, not many people understand what radians mean. Most people know how to convert from degrees to radians and vice versa, but it ends there. To understand what radians mean, let's draw a circle. Let point O be its center and length R be its radius. Now let me take this length R and place it here at this point. Now all I do is push it onto the circumference of the circle. The length of this red part is still R, it has just become curved, and that's all. The curved length R starts from here and ends here. Now, from the center of the circle, we draw another radius that joins the other end point of the red curve. This length will also be R as it's the radius. Let's analyze the figure. We have an arc of length equal to the radius of the circle, and two radii joining the center and the endpoints of that arc. Remember, the length of the arc is equal to the radius of the circle. This angle formed here is 1 radian. That's the concept of radians. Actually, there's radius everywhere around this angle. R, and that's probably why they call it radians. According to various scientists and mathematicians, this is a more logical way to measure angles. It's because we are measuring the angle in relation to the radius of the circle. But how are radians related to degrees? What would this angle be equal to in degrees? If you understood the concept of radians well, then understanding the conversion between degrees and radians would be a walk in the park. What is the circumference of a circle? It's 2 pi r, where r is the radius of the circle. We are talking about the circumference, which is the entire boundary of the circle. Now listen to the next question well. How many such arcs would you need to cover the entire boundary of the circle? Let me repeat the question. How many such arcs of length r would you need to cover the circumference of the circle? Pause the video and see if you can work through this on your own. The length of the arc is r and the circumference is 2 pi r. Yes, 2 pi r. It means we would need 2 pi such arcs to cover the circumference. 2 pi arcs? What does that mean? As pi is approximately 3.14, we would need 6.28 arcs to cover the circumference. How would it look? This is 1 arc, 2, 3, 4, 5, 6, and a little part left for 0.28 arc or 28% of an arc. So we need 2 pi arcs to cover the entire circumference. And what does each arc correspond to at the center? We have seen that 1 arc corresponds to 1 radian at the center. It implies that to complete 1 full rotation, we would need 2 pi radians. And it tells us something more too. If we rotate 1 arm completely, then 2 pi radians will be covered at the center. But wait, hold on. We also know that 1 full rotation equals 360 degrees. Yes, 1 full rotation equals 360 degrees. As both equal 1 full rotation, these two will be equal. 2 pi radians will equal 360 degrees. That's the relation between degrees and radians. This is what we have been working towards in this video. If we understand this, we can easily derive the rest. This is 1 full rotation. Then how many radians will 180 degrees be equal to? If we divide this equation by 2, we get pi radians equal to 180 degrees. And 180 degrees is half circle or a straight line. And what about a right angle? If we divide this equation by 2, we get pi over 2 radians equal to 90 degrees. So a right angle is equivalent to pi by 2 radians. These three relations are most important when it comes to conversion between degrees and radians. And we don't really need to remember all three. Knowing just one is enough and we can derive the rest. And now we come to the last and the most important point of this video. What does 1 radian equal to in degrees? If we divide the first equation by 2 pi, we get 1 radian as 360 over 2 pi degrees. Substituting the value of pi as 3.14, we get the approximate value of 1 radian as 57.2958 degrees. That's the degree measure of 1 radian. If we have an angle like this, which measures 1 radian, it will equal 57.2958 degrees.
Okay, so I know she went fast, so let's break it down. Ready? If you draw a circle, we think of a circle as, oh, we have 360 degrees in a circle. Okay, that's kind of an arbitrary measurement. Radians makes more sense as far as talking about what are the angle measurements that are in a circle, okay? But it's a new concept, so we're still kind of going to be degree people. I'm still a degree person, even though radians really does make more sense. It's just like inches versus meters, right? As versus centimeters, I should say, as far as like measurement. The meter system, the metric system makes more sense But have I grown up with inches and feet and yards? Yeah, so that's where I think, even though it doesn't make as much sense, right? So that's where we're adding a different way to do the same measurements that should make more sense for us, okay? So angle measures in a unit circle are talked about in terms of radians because every circle has what we call a radius. And we know it is the value from the center of the circle out to an edge of the circle. And we also know there's an infinite number of radii. It's a Latin word, so that's its plural. There's an infinite number of radii that make up a circle. So this is just one arbitrary radius that I have drawn from the center to the outside of the circle. Now, if I take that length and just kind of stand it up and then attach it to my circle, so curve it back onto my circle, what we're saying is this is the length of a radii and this is the length of a radii. Okay, so we're equaling those guys. If we then draw another line from the center to this end point of that radii, now you've got this angle surrounded by radii of the circle, radiuses, if that's how you want to think of it. That angle right there is one radian. Okay. It is a more logical way to think about angle measures in a circle because of the radius deal. All right. Now, again, we all use degrees because that's how we're brought up. That's how we start, right? Even though it's so arbitrary, it's how it goes. So, how do we convert from degrees to radii and back and forth? If we know that our circle is 360 degrees and we mark how many radii fit in our circle, okay, we know what we end up with is 2 pi number of radiuses in our circle. And that makes sense because if you think about it, the circumference of a circle is pi times the diameter, which is 2 radiuses. That's where that comes from. So we're talking about the whole length around. Each of those then are those angles inside that circle. Okay? Right? So the circumference of a circle. And of course, we know that the diameter is 2 radiuses. So that's why it's 2 pi r. Okay? That also means that since pi is approximately 3.14, from here to here, there are 1, 2, 3, and a little more, and a little more, and a little more, and then left right here, right? So 1, 2, 3, 4, 5, 6 fitting, but there's just this little bit left. Think about that, right? Think about what that little bit left is. 28 divided by 2 is 14. There's your 0.14. Okay, so that's why we say we get pi times 2, making up a whole circumference of our circle. So if 360 degrees is the whole degree measure of the circle, and 2 pi radians is the whole degree measure of a circle, then that full rotation is equal to each other. And you take and divide both sides by 2, well, that tells me that a straight line, 180 degrees, is the same as having pi radians. So approximately 3.14 radians. And then if you want to know your right angle, which that will be very important, you take and divide again by 2. That means this is pi divided by 2, and this is 90 degrees, getting you that right angle. So if you do that again, then you'd get a 45-degree angle, and it would be pi over 4. Okay? So that's how we use these specific conversions help us figure out any other degree conversion as far as radians go. Think of it as when talking about radian measure, you're going to have a pi involved. And when talking about degree measure, it's going to be this degree symbol involved. And so when we bounce back and forth, that's how you know which measurement you have. Okay. The radians will have a pi involved, and degree measurement will have the degree symbol involved and will be numbers between 0 and 36 for one full rotation. Okay. So that is where we get to at the very end of the video. As you know, we know that 1 radian is equal to approximately 57.2958 degrees, approximately 57 degrees. Okay. We're going to use this to help us go back and forth, convert back and forth. Okay, so let's convert between radians and degrees. So this is something, this first piece, that you'll want to kind of apply, but I'm going to teach you a little bit of a go around as to how to figure out which one to use, right? So if you're changing from radians into degrees, you're going to multiply that degree 180 divided by pi, okay? If you're changing from degrees into radians, it's the opposite. So you're like, wait a minute. How am I supposed to keep that straight? Got something for you to keep that straight. So remember how I said you can kind of think of this as the radians are going to have the pi involved and the degree measures won't? That's how we keep it straight. So here, okay, we're going to convert pi over 5 radians into its equivalent degree measure. So what you do is you start with the pi over 5 and you multiply it by 180 divided by pi, because I'm converting into degrees and I want pi to cancel out. So pi over pi is now gone, and really what I have is 180 divided by 5. So take your 180 and divide it by 5 to get our angle measure in degrees. So pi over 5 radians is, oh, let me make that bigger so you can see it, 36 degrees. Okay, let's do that one more time down here, right? 8 pi over 3 radians times 180 over pi. Well, the pi's cancel out. On top, you've got 8 times 180, and then you divide it by 3, right? So 8 times 180 goes into your graphing calculator, and you get this. And then go ahead and divide that guy by 3. You get 480 degrees. So this is greater than one circle. Okay. Now the opposite is true if you're starting with degrees and want to convert that into radians. You need to have a pi, and it needs to be in the numerator. So, because you can't have irrational numbers in the denominator, right? So we want to take our degrees and multiply it by pi over 180. So essentially, you end up with a fraction of this degree measure divided by 180 and multiplied by pi. So you get your 50 degrees, right? Multiply it by pi over 180. And this is basically what you get, and then simplify. You get 50 pi over 180. Now, since we're going to want to keep that pi, so we have the closest rational equivalent, we're going to keep that pi as our symbol here. What you really do is throw 50 over 180 into your graphing calculator to simplify it. So 180, excuse me, into our graphing calculator, and we simplify. Now that's not helpful, but when you press math fraction and convert it into fraction form, there you are. We could really essentially just cross out the zeros, okay? So you get 5 pi over 18 as the equivalent radian measure to 50 degrees. Let's do it again. 250 degrees in your circle, right, is multiplied by pi over 180. Now, again, I know that the pi needs to be on top because I'm taking degrees and converting it into radians. So essentially, I get this 250 pi over 180. And now in my graphing calculator, I'm just going to type in 250 divided by 180. And I get this, which Means nothing to me right now, but I need it in fraction form. So math, enter, enter. There we are. So again, the zeros just cancel out and we keep that pi involved in the numerator. That is our conversion into radians. Okay. That's where we kind of start using radian degree measure, using radian measure coupled with our degree measure, so that we can start to look at these very specific angle measures like 30, 60, 90, and 45 degrees, and then continue that in the other three quadrants. So these are very important conversions. Now, these, it's smart to get to know, but when we put them in the unit circle, I am going to teach you how to get to know these conversions. We are going to really know that 30 degrees is the same as pi over 6 radians. We're really going to know that 180 degrees, that straight line that we talked about in the circle, that diameter straight across, right, is the same as pi number of radians, approximately 3.14. So then it would make sense that you multiply that by 2 for 360 to get that 2 pi number of radians, approximately 6.28. And that all goes back to this initial picture right here that has 1, 2, 3, 4, 5, 6, and then 0.28 left. 2 pi. Okay. That's where that all comes from and goes back full circle, if you will. So that is what we want to be able to do on our homework, is just convert back and forth between radians and degrees. That's where we want to start. Okay. Use those little pieces that I've helped build with you to help you go back and forth. Again, remember, radians are going to have the pi involved and degrees aren't. So that reminds you where you multiply by pi on the top or where you multiply by pi on the bottom, right? So when you want that canceling out of the pi. Hopefully that helps you. Okay. This has been your Chapter 9 Lesson 1 video, and hope it goes all right. And if not, I'm more than happy to explain this further. I will see you guys soon for some angle terminology and putting some angles in the coordinate plane. Good luck, guys. Have fun. See you soon.